continue. So what do we know so far about our linear systems? What do we know? We can solve linear systems 3 different ways. You can graph them and find the point of intersection. The best part about this is I think that it's easy to understand, right? What is it we're trying to do when you solve a linear system? What point, what xy pair exists on both lines? That's what we're doing. So graph the lines and look. What are some of the pitfalls of this, though? Of the graphing method? What's some of the problems? Yeah, like what if your x value is 2.1? You can't tell by looking on a graph you have 2.1. Yeah? Like if your y value, your y-intercept is like up here someplace, they're hard to graph sometimes. So this can be hard sometimes. Sometimes it's not. And we talked about how you can maybe use the graphing calculator sometimes to verify some issues just by graphing them. But sometimes that's more work than it's worth, right? So I love this only because, yes, I get it. I'm looking for a point of intersection. Got it. But because there's some pitfalls, we use algebraic ways of doing this too. So the first way is substitution. So substitution is when one of the equations is solved for y or it's solved for x, right? And the other one, maybe it is, maybe it isn't. I don't know, whatever, right? And then you substitute in the other value. You have an equation to solve in one variable. You find the x, maybe you plug it back in, you find the y. Elimination is when you have two equations in the same format. And I'm just making numbers up here. I don't know what the solution is. I'm just putting stuff down. And you would add it till one eliminates, find the other variable, plug it back in just like in substitution to find the one you didn't find the first time. All of these you need to, actually verify. Okay, be honest. Who actually verified your solutions by plugging it back in to both equations? Wow! Wow! That's awesome!
You should get a prize!
You should get a prize. Virtual gold stars for everybody with a hand up right now. Yay! Do you know if you had it correct? I mean, isn't that nice? You know right away, do I have it correct? Do I not have it correct? A hint for me to you is when you don't get these right, you did this and it doesn't work. What I do is I kind of like circle the problem, go away from it and leave it alone, do anything else, and then come back later, fresh sheet of paper, and do them so you don't keep making the same mistakes. But anyway, so we found when we were eliminating variables that sometimes you couldn't just add them because we had stains. And so we would multiply one of the equations through by -1, and it would give us opposites. We also did multiplication through to get rid of fractions. And the fractions are kind of hard to work with sometimes, if not all the time. So you can multiply through equations with a number, and you still get equivalent equations. And we're going to take advantage of that. So let's see what I got here. Sometimes we can't just add or subtract when we have our linear system equation. So let's look at this example here. It is on your paper, right? Side 1. I keep hearing some level of noise. It's driving me crazy. It's humming. It's this. It's whatever. Please pay attention to this. Please. Okay. Let's see what we got here. Sometimes we can't add or subtract. 5x plus 2y is 16. 3x minus 4y is 20. So I look at the x's. I look at the y's. Same or opposite? No. Same or opposite? No. So I can't just add them. I won't eliminate a variable. So what you do is I'm using, some math words here. Least common multiple. Look at these coefficients. See the 5 and the 3? What's a least common multiple? What is that? Matthew, what is that?
It's like a number that
that would be a common factor. So least common multiple, what's that? Like what? Let's say I want 3 and 5. Least common multiple. What's that multiple? 3 times 1, 3 times 2, 3 times 3, right? 3 times 4. Aren't these multiples? And then what are multiples of 5? Right? Common means the same, right? Least means smallest. So what's the smallest multiple that's the same? 15. So the least common multiple multiple on 3 and 5 is 15. I can do the same thing with the 2's and the 4's. What's the least common multiple? We're ignoring sign for now, just between 2 and 4. 4. Yeah, because right, 2, 4, 6, 4, I don't even need to go any further. They're here, 4. So we're using that skill here. So you look at the x's, you look at the y's, you say, well, this least common multiple is 15, and this least common multiple is 4. Okay? And then you're going to multiply through. So I'm going to turn this away for a second. So you say, gee, how do I get these to be 15? I have to multiply this by 3, and I have to multiply that by 5, right? That's how I get these to be 15? Now remember, if you multiply through everything, how would I get these to be 4's? I would multiply, I'll put it over here. I'll multiply this by 2. Do I need to do anything over here? Which looks easier? Multiplying by 3 and 5? Or multiplying just by 2? Yeah. So that's the kind of analysis you do. Understand, let's see, I'm just going to multiply the top by 2. There's nothing wrong with multiplying the top by 3, multiplying the bottom by 5. Everything works. But I like doing the least amount of work, not only because I like doing the least amount of work, but I'm less likely to make mistakes. So, yes, I'm de-simplifying it. Yes, I am. Making it bigger. So, everything. What gets multiplied by 2? Everything. So, where are these numbers? Where did I get all these numbers from? Times 2? Times 2? Times 2. Hopefully I did that right. And let me copy the bottom one. I'm not changing the bottom one at all. Look what I got. Opposite. Now what if I had done it the other way with the 3 and the 5? Let's just do that for fun. 3 is fun. So that way I would say, well, let's see, 15x. Where am I getting these numbers that I'm writing down right now? Multiplying the top by 3, and then the bottom. Where am I getting these numbers? Okay, now is that good enough? Thanks, right? So what should I have multiplied by? -3. Okay, or -3. And so, huh? How am I? 5 times 3, 5 times 4, 5 times 2.
Wait, are you multiplying like 2 more?
No, well, I'm trying it the other way.
Oh.
I'm trying to show you can do it either way. Okay, now you want to look, and if you are working with x's and they are the same sign, one of these has to be negative. So let me fix this side. Let's see what happens when I solve them. So let's see. So that's 13x, right? Equals 52. So x is 4. I think, right? I did that right. Plug that in. So 10 times 4 is 40. What's the matter? Did I make a mistake? Yeah, what I do?
Is it possible is it allowed to do another line too?
Yes. As long as it's everything. The dividing 2 is like multiplying by a half. So yes, you absolutely can. 4y is whatever 32 minus 40 is -8. So I think I'm getting y is -2 when I solve this one. Question?
Oh, what if you multiply by 2?
I'm doing this actually 2 different ways. You don't have to do both these things. So the first one looks easier to me. I only had to change one equation, and that gave me my opposite, so I stopped.
Yeah, but how did you like define 2?
How did I know to do 2? Because I looked at 4 and I looked at 2 and I said the least common multiple is 4. And that's already a 4. How do I get this to be a 4? Multiply by 2. So you multiply everything. Now let's, yes?
Wait, why did you like times by 3 times by 6?
Okay. Then I said, remember I said you could either work with the y's or the x's. So I did the question a different way. So I personally would have just done this and stopped. But maybe you chose to change these. So I wanted to show you how you would do it.
Okay.
So 3, because I wanted these to be 15s. Because that's the least common multiple here. So let's see if we get the same thing. That's 26y equals 148. Oh, goodness gracious. What is 148 divided by 26? It does not look right. Let's see. I made a mistake someplace in there. That's not, boy, I made a mistake. Let's see if we can find it. Oh, it's negative. All right, let's right now. I changed it. So 26y equals negative 52. That's way better, right? Divide by 26, you get y is negative 2. Plug it into one of the equations. Oh, here, when you're plugging in. So 5x plus 2 times negative 2 equals 16. 5x, that's a minus 4 equals 16. 5x equals 30. X is 4. So you can go either way. Either make the x's be opposites or the y's be opposites. It doesn't matter which way you go. Look for what you think is going to be easier. Okay, so we're just eliminating it. Let's see what else we got here. So let's see, the steps. What are the steps? How cute is that? I think we're almost on track here. I'm just kind of verbalizing what you have to do here. Step 1, you multiply through one or both equations. I don't know, it depends. With some constant number so that you're going to get a variable dropping out or eliminating when you do the addition. And then you just do what we did last class, right? That's really the difference today. You find least common multiple. So here's another example. We are on page 2. 4x plus 5y equals 35, and 2y equals 3x minus 9. So, oh no, first things first, which is what? Oh my. Yikes. Oh, what do I have to do first thing? Oh, what?
You have to make the bottom equation or the top equation match each other, so you have to put the 3x on the side.
Awesome.
On both sides.
Absolutely. These are two different formats, okay? So we have to make them agree, right? Rearrange the terms. He said, put this one over here. So we're going to subtract the 3x. We can do that. So now what do I have? The top is 4x plus 5y equals 35. And now the bottom is negative 3x plus 2y equals negative 9. Yeah? Yeah, I just want to make sure I did it right. Did I do it right?
Yes.
Okay, great. So now we all match. So now I don't have opposites or same. So you have to do an analysis to say, let's see, maybe I want the x's to drop out. So what would I do then to make the x's eliminate?
We're not trying to least common multiple now.
Okay. So then how would I get this to be a 12?
I was doing 3 and 5.
Well, let's see. Let's just do the numbers first. You say 3 and 4, right? Now these are already opposite sides. It's automatic. Okay, so that's how you do that. And maybe that's the easiest, maybe it isn't. I always check what does it take to change my y's? Well, what's the least common multiple here? 10. So what would I multiply this by? 2. And what would I multiply that by? Well, negative, right? Because these are same. I don't know, what's easier? Pick one. You want to do this one? Who wants to do 3, 4? Raise your hand. We'll take a vote. We'll do this democratically. Who wants to do 3, 4? Me. And I'm actually raising my hand for that one. Why am I raising my hand for 3, 4? Well, there's no negative. And anybody ever do the negatives and get all confused? Come on. Yeah. I'm my hands up.
Raise more.
Of course. And so I would, and if it's not, if that's easier to you, absolutely. I like multiplying by 2s and 5s. I make less mistakes. Choose 2s and 5s. But I think I'm going to go with the 3s and 4s. So you decide. There's no right or wrong answer here. The only right or wrong thing is that everything gets multiplied. So let's see. That becomes a 12x, 3 times 5y, 35 times 3, I don't know. It's 35 times 3. Too lazy to try to do that. 25? Is that what we're getting? And now this by 4. Negative 12x plus 4 times 2, 8y equals 4 times negative 9. That's a negative 36. I got my opposites. What is this here? I don't even know what this is. Oh, yes, add them and solve. Okay? So now we're just like what we did last class. Nothing's different now. That goes away. 15y's plus 8y's. How many y's? 33 y's? Is it? I don't know. Yeah. And then 105 plus a negative 36. That's subtracting, right? So that's a 9. Is that that? Is it? 69. Yep. Okay, then I divide both sides by 23. This is looking promising. say, okay, I plug it in, I try to, when I can, go back to original equation, just in case I mess up here. So which one do you want me to use? Top or bottom one? First one. First one? Okay. So 4x plus 5 times 3, that has to equal 35. So that means that 4x plus 15 has to be 35. So I'm going to subtract that 15 to get 4x on its own. So we get 20.
Yep.
And x is 5. It looks, yes we do. Because look at all this. That's me doing this. I probably made a ton of mistakes. I don't know. The only way I know if I did or I didn't is to check the solution. So 4x, I think x is 5, plus 5y, I think that's 3. Does that equal 35? 20 plus 15, right? Oh, that's looking good. So the work's in the first equation, so am I done checking? Am I good? Am I done checking?
Check both equations.
Okay, so be careful where you put your x's and your y's. This one's a y and this one's an x. The 6 equals 15 minus, no. Yeah. Okay, all right. Checks, checks. I got the solution. Woohoo! I know where these two lines intersect at point 5, 3. This 5, 3 is the solution to this equation and that equation. Kind of it. Yeah. That's it. So I want to concentrate some on the word problems. Word problems are why we do things like this. Here's something for you to, I don't know, you want to cross-stitch this on a pillow somewhere? Life is a word problem. Right? And so in math we learn how to solve them.
Life is like a root.
Life is a word problem.
What?
Like this one. So look at my cute picture here. Brenda's school is selling tickets to a spring musical. Word problems. Here's how you kind of do these. After a while, you will notice, you know what, all these problems are kind of the same. Or, you know, I kind of know how to approach them. So we're selling tickets to a musical. See, look, here's the musical. They're singing the person, okay? So on the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets. So I guess they're different prices, the different tickets. They made $75. They made $67 on the second day by selling 8 senior citizen and 5 child. So I kind of like, what's important here? 3 senior citizen tickets and 9 child tickets for $75. And $67, now they're wording them slightly differently, but basically 8 senior citizen tickets and 5 child tickets made us $67. This is kind of the important bit. What are they even asking me for? What's the price each of 1 senior citizen and 1 child? Question. Okay, hang on. So how do you do these? The first thing you have to do is define your variables. And I'm going to, what do they want me to know? What's the price of a senior citizen ticket? I'll make that X. The price of a senior citizen ticket, I'm calling X. And I'm going to let Y be the price of the child ticket. These are the things they want me to find. This little statement here is actually kind of important. It's really going to help you organize your thoughts. So don't skip this little let statement. Let X equal the price of a senior citizen ticket, and let Y equal the price of a child ticket. And then we're going to figure out how to turn these into equations. So Claire, I think we found maybe just one of the equations. Or if it's 3 senior citizen tickets and 9 child tickets for $75, how can I write that as an algebraic equation? Now how'd you get that? That's my X, right? 3 of them. That's how you calculate cost, right? However many of the senior citizen plus however many of the child ticket, that's how you get your cost. So this was day 1. So, you have a question? Or do you know day 2? Yeah, what's day 2 then? Awesome. Does this make sense?
Yes.
Okay, then that's it. I mean, to me, that's the hard part. Can you come up with what the system of equations are? Who has questions on where this came from? Okay, now it's solving. And I'm looking, now we look for sames, we look for opposites. Don't see it. So now this is kind of that new step, which is how can I make them same or opposite? So if I'm looking at x's, wow, what is the least common multiple there?
24.
It is 24. So I have to multiply the top by 8 and the bottom by 3, and one of them needs to be negative, right? And the same sign. Let's look at these. What we got here? 45. So I have to multiply by 5 and by 9. One of them has to be negative. Which way you want to go? Why did you do I heard more 3s than 8s. She loses once again. All right, so what do I multiply this one by? Now, these are sings, right? Same sign. So one of them has to be negative. Who do you want to make negative? 3. So now we're going to rewrite all these things now. Oh, some of these are going to be big numbers, aren't they? So 24x plus 8 times 9. 72y equals, oh, what's 75 times 8? Who's been there? What do we get? 600. Okay. This one I'm multiplying by negative 3. So that's negative 24x negative 15y equals negative what? 21? Okay. And I've got my opposite, so I can add, goes away. 72 minus 15, right? These are y's. 12 minus 5, that's a 7. 6 minus 1 is a 7. And this one, well, I know 600 minus 200 is 400, so let's see, 399? What? No. 72 minus 15 is a positive 57.
Yeah.
And then, yeah, okay, so now I have to divide by 57. Of course, that's a nice little number.
Yes.
Now what do I find? Here's where your let statement helps you. Y is the child ticket, so I guess that's $7. So this let statement helps me keep track of what did I just find. Because my job is to find a senior citizen ticket price and a child ticket price. So I think I found this one, $7.
Did you draw this link at the bottom?
I did not. I'm not that good, which tells you something about my
Oh,
artistic
that
ability.
doesn't look that good.
All right, now we go back to one of these. I don't know, just randomly picking the top one. 3x plus 9y, which I think is 7, should give me 75. So 3x plus 63 should give me 75. So 3x equals, well, subtract the 63s, right? Looks like a 12. So x is 4. Well, what's x? X is, oh, my senior citizen ticket, $4. I don't know. So, check it. Plug them back in. It's 3 times 4 plus 9 times 7. Do you get 75? Just run that through your calculator. Does it work? You running it through?
Yep.
That was easy. I like
And
that.
then you take 8 times 4 plus 5 times 7, so you get 67. Run it through and check it. Check. And then you know I got it right. Okay, let's try another word problem. No, I have another word problem. I got it. Where is it? Oh. Thank you for knowing that. Okay, yeah, these are, wow. Okay, I can't read my own writing. There is another one. This is a practice one. Maybe I will let you do it a few times. Good idea. So I'm putting up what I got for these. You actually don't need my answers, right? Because you're verifying your solutions. But here they are. You want me to do one first? A?
Yeah, can you do A?
So I looked at the x's and I looked at the y's. Quiet, please. So to change these, what's the least common multiple here? 6, right? So I have to multiply this by 3 and this one by 2, except they're the same sign. So one of those would have to be negative. And then I'm looking at this. Well, the least common multiple of 5 and 10 is 10, right?
Yeah.
So I just have to multiply the top by 2. However, I want them to be opposites. So I think I'll multiply by negative 2. So then I get negative 4x minus 10y equals negative 6. we get here? 3x minus 4x is a negative x. That's a 0. And that would be negative 9. I don't want negative x, I want positive x, right? So how do I get a negative x equals negative 9? How do I get that positive x? Multiply by negative 1, x equals 9. That's where that came from. Pick an equation to plug it in. Doesn't matter. Let's try the top. 2 times x plus 5y equals 3. 18 plus 5y equals 3. 5y equals, whoa, I have to subtract 18, right? So what's that, negative 15? So y equals negative 3. That's where that came from. And I plugged them in to check them. Make sense? Yes, ma'am? See? 4x, x is here, so I'd have to multiply by 5 and 4, right? To get 20. 1 would have to be negative. 3 and 2, least common multiple is 6, right? So I have to multiply by 2, and by 3, 1 would have to be negative to get opposite signs, right? I think I'll use the smaller numbers. It really doesn't matter. You could do the other way. I'm going to do the 2 and the 3. And I'll make one of them negative, so that the signs will be the opposite. So I'm getting 8x minus 6y equals 16. That's all these numbers multiplied by 2. And then the bottom multiplied by negative 3. Careful now because of the negatives, right? All these signs should be opposite, and they are. That becomes negative 7x equals 49. So that means x is negative 7. That's where that came from. Plug it into either equation, does not matter. And the top one, negative 28 minus 3y equals 8. Add 28. So divide by negative 3, I'm getting y is negative 12. That's where that came from. And then check your solutions in both equations. Okay? I want to get to that word problem. So just pause for a moment. If you haven't gotten there yet, take like a second and work on the word problem if you haven't tried it yet. At least see if you can get the equations going. If you're not sure where to start with this, it looks like we're having a field trip, right? So high school A, let's call it Briarwoods High School. Let's do that. High school A. And then high school B, we'll call it Stonebridge High School. Okay, so the senior class at Briarwood, they rented and filled 8 vans and 8 buses with 240 students. And at Stonebridge, they filled 4 vans and 1 bus with 54 students. Briarwood sending more. That's good, right? Great Briarwood. That's awesome. Every van has the same number of students in it as do the buses, okay? So what am I finding? The number of students in each van and in each bus. Make a let statement. Let x equal the number of students in a van, and let y equal the number of students in a bus. So this is what I'm trying to find. So when I set up an equation, do you have an equation for me, Judy? Yeah, so what would be for Briarwoods High School, School A? Okay, tell me how you got that. Mm-hmm. 8 of those. What's my second equation? Somebody else. Yeah, that was the second equation. Right? So high school B, Stonebridge, they had 4 buses with X numbers, or 4 vans with X number of students, 1 bus, 54. You've got this. Now you can go solve it. Now you're going to know if you have the right answer based on, plugging it back in. But I'm just going to put up on what I got, and we'll see if we match. Anybody finish it yet? Do we match?
Yeah.
Yes.
You solve this linear systems, that's what you should get. But I think it's important to have this let statement here. So when